I mentioned this before, but we have been doing a limit. This whole idea, I wrote, like after the very first time we did our tables, that what we had just calculated was a limit. And so today we are going to start using limits in the proper notation. So this is like something we have been doing. If I wanted to know what the y value was as x got near 2. Notice I'm not saying at 2, I'm saying near 2. So if I just said estimate y when x is close to 2, you would plug in values getting closer to 2. So we would go from the smaller side to the bigger side. And so we can see in this table our x is getting closer to 2. What is our y getting closer to? 4. And same thing over here. This x is approaching 2. This y is approaching 4. That's the idea of a limit. What that means on a graph is, this is the graph of that function. If you are traveling along that graph, as you are getting closer to the point when x is 2, the y value is getting closer to 4, and that works from both sides. As your x is getting closer to 2, your y is getting closer to 4. We understand that? Agree with that? Notation-wise, what we will write is limit, and then underneath it, or kind of off to the side, we say as x approaches 2. So we're telling ourselves as x is getting closer to 2 of this function, that's the equation I was looking at, equals 4. Thank you. Where's this? Your application.
Are you mistake altogether?
Hang on to it. Are you bringing it to me for you today?
See, I really can't see if there's a good teaching class right now.
Okay, you want to come back to the class? So, as our x's are getting closer to 2, the y is getting closer to 4. That's our notation that we're going to see. The next slide, I just put like the actual definition if you're looking in your book. If you want to see it, same idea. The limit as x approaches a specific value of your function is equal to L. And that's just kind of a reminder of how we say it, the correct wording. It could be written differently. An alternative notation is to say f of x approaches L as x approaches A, saying your y is getting closer to this limit value as x is getting closer to a specific number. I don't really use that notation ever, but you might see it somewhere, so just know that's the same thing as a limit. All right, the key here, and this is always really hard, but a limit, we don't care what happens at the number, only as we get close to the number. Okay, on the one I was just looking at, that seems really silly because when x is 2, isn't the y 4? Yeah, so at the number is the same thing as our limit, but it doesn't have to be. If we look at these 3 graphs, okay, here we can see this is an actual point on the graph. But this one, we have an open circle up here and a dot down here. If I ask when x is equal to a, you're going to give me some number down here, right? But that's not the same as the limit. The limit is saying if you're traveling along this graph, getting closer to a, what is your y getting closer to? So this graph, my point is not on here, but it doesn't matter. Same thing, even if I just had an open circle. That means a isn't even a part of the domain of this graph. There is no actual y value when x is equal to a. But these all have the same limit. So limit does not matter what happens at the point, just as we are approaching the point. So let's look at an example. If I want to estimate the value of this limit, first of all,
There's a whole...
we have as x is approaching 1. Can you plug 1 into this equation? No, you would get 0 over 0. So does this graph even exist at 1? No. Does that matter? No, because a limit doesn't care what happens at the point. It's as we are approaching it. So we're going to make these tables similar to what we were doing before, except we don't have to do as much because I don't need a slope here. I just need to know what my y is getting close to. We still need to approach 1 from both sides. We haven't seen the case yet, but we will later today where they don't match. So we have to check both. So I need numbers smaller than 1, so maybe 0.9, 0.99, 999, and then things bigger than 1, so maybe 1.1, 1.01, 1.001. All right, 0.9. Angela, 0.99, 0.999. Sam, 1.1, 1.01. You two, 1.001.
What if I check every way? So we can say every vote 1.0?
No.
Oh,
You are 1.01.
oh.
Don't mess up.
Okay. It's okay, good. I can check you. Yeah.
No?
Advisor was at 10:40. Yeah.
Huh?
Advisor was at 10:40. Yeah. 10:40. Yeah.
Yeah, 10:49.
I'm trying to remember what time to put this.
All right, what'd you get for 0.9?
Negative 1.1224567. No. No. No.
That's not what. Wait, hold up.
No.
Let's check.
How about 0.5263?
What?
Yeah.
I'd say it's a parenthesis issue.
Oh.
What about 0.99?
I got 0.50251.
Okay, 999.
Oh, 0.500250125.
Okay, Sam, what about 1.1?
1.476.
Grant,
4975.
Carson, and Grayson.
0.499750.
Okay. So we can see my x is getting closer to 1. What's my y getting closer to?
5.5.
Is that the case in both tables?
Yes.
Yes. So we would say the limit as x approaches 1 of x minus 1 over x squared minus 1 is 0.5. And hopefully this shows you that I don't care at the point because we would not get 0.5 if we just plugged in our 1. Okay, it doesn't exist. But the limit is approaching that value. Uh-huh.
Why does it estimate the value? Why is it?
How do we know for 100% certain that we're correct? What if it's actually 0.500001?
So there's no actual.
We are trying to convince ourselves right now. Okay, we're doing our best. We are fairly confident
I'm good at
it's something in between 0.5003 and 0.4998. Would we agree with that? We're picking 0.5 because it's the nice number in
The
between them.
middleist.
But do we know with 100% certainty, would you bet your life that it's 0.5?
Probably.
Sure, why not?
But
Yes, because I told you it was the answer.
There's always
Most
a
certainly
chance.
should. But there's that chance. So we are estimating these right now. As we go through limits, we will learn how to find them exactly.
Really?
Right now we're trying to wrap our minds around what a limit does.
Really, it wouldn't be 0.5 because it's not even. That's not the middle.
Yeah, that's not the true average. So we
3
really
points on one side
just
and 2 points
kind
on
of
the other.
estimated what we think it is.
Nah, it's still 0.5, trust.
Not interesting.
All right,
Just,
let's see if we can figure out what this one might go to.
just the same, like estimate the
Yeah.
same.
So, we make our table x and y or x and f of x. What x are we approaching?
-2.
No.
No.
3.
3.
Okay, so we need to be smaller.
Whoops. My bad.
And and we need to be bigger. Are we okay with just dividing up the work every time? You guys want the same ones every time?
No.
You're 2.9, Angela 2.99, Caitlin 2.999, Sam 3.1, Grant 3.01, back corner 3.001.
So it's 4 decimal places like that.
Yeah, should be close enough. Right.
Uh,
What'd you get?
0.387 rounded up to 0.387.
Okay. Angela?
I got 0.3988.
Okay, Caitlin?
3999.
Sam? What? 0.499?
What?
Okay, let's double check it.
411.
Grant?
43944. I got 44012.
Yeah.
Grant Yeager.
Carson, I thought you said you were
401.
gonna check his work every time.
Grant would,
Oh,
or,
I did
Carson,
check
what'd
his
you
work
get?
every time. 0.4001.
Okay,
I don't know how it changed.
probably a parenthesis.
I don't know. This one looks like it would be 4, so.
So what does this approach?
I'll take it.
0.4. Alright. So far, so good? Let's try another one. Could I just plug 2 into this if I wanted to? No, this one is not defined at 2.
Oh, that's crazy. It's a little bit
Same
more
thing.
X and
complicated.
X, same.
Investigate.
What do my X's need to be approaching?
Probably 2.
So we need smaller than 2. Bigger than 2. Alright, plug in your respective numbers.
1.99 squared minus 4 over 1.99 squared plus 1.9 minus 6.
1.9.
1.99.
Oh, second one was another 9.
Right, 1.
7996.
Alright, Caitlin, what'd you get?
0.79996.
Alright, Sam? Grant?
0.8004.
Carson? And Grayson?
0.8000.
Alright, so what do we think this limit is?
5.8.
Are we understanding our process here? Let's try some more. Okay, if I wanted 0, alright, give me numbers smaller than 0. Okay, and bigger than 0. Alright, do we need to mix it up? Are you guys getting tired of doing your same numbers every time?
No.
Okay. -0.1. Negative 0.01.
Point 1 0 0 1. No, yes.
One more
Just-
O.
Just 3 O's. I have 3.
Okay. And then a 1.
Yes, sorry.
Alright.
1, oh, 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 1.
Ooh.
Okay. Positive 0.1.
Same.
Uh-oh. Okay, what'd you get for? Okay. What's?
Yeah, no,
Okay, let's check.
that's a little.
I got 0.09.
So for positive 0.1.
Okay, I'll take care
Positive 0.1, I get 0.0999. So for positive 0.01,
of it. 0.0999. Structure which we got in mind, correct.
and for positive 0.001.
Ooh, please,
So, our limit as t approaches 0, square root of t plus 25 minus 5 over t is equal to
Point.
0.1. Alright, calculator hint. We seem to really be struggling plugging these in. Okay, if you are using a graphing calculator, what I want you to do is hit alpha, y equals. And now you can see it as a fraction and make sure you are plugging it in exactly as written. Okay?
Oh, wow.
So that is my suggestion if you are struggling to plug things in.
It's just
You're
parentheses.
welcome to borrow one of mine.
Oh, this
You like yours.
Guess. Oh, that's just the same word. Okay.
Yeah, same thing.
Why do we got so much
Because
nomenclature?
I am just showing you my wide
You have very large
vocabulary.
nomenclature.
Yes.
Yeah, what did we get?
Okay, guess the value of the limit as
Oh.
x approaches 0 of sine x over x. Did I plug in a 0 here? No, that won't work. Okay, so my x's that I'm plugging in would be the exact ones we just did. Because I'm approaching 0 again. Something we do need to do. At the very beginning, I told you in here, anytime we are dealing with a trig function, has to be in radian. So make sure you are in radian mode.
Oh, how do we move?
Make sure it says radian.
I like check to make sure.
So if I'm,
Like kind of a radiant answer what I get out. That's what you.
well, let's see. If we put in sine negative 0.1 divided by negative 0.1.
Oh,
We
we get
get-
an error.
0.9983.
What is
Yeah, I
this?
don't have that.
Get yourself a calculator, Caitlin.
Oh, I
And then once I typed it in the first time, I just hit second enter to bring it back. That's what I do. And then I insert my zeros. So we get 0.49s and then an 8.
I did something wrong. Oh, it was point ones. That's wrong.
So if I did it again with my negative 0.001, we get a lot of 9s.
I found it. Gradient.
But are they both supposed to be positive?
Yep, you're changing every x.
Yeah, but like is it 8 times?
Yeah.
Oh.
Mm-hmm.
嗯
Mm-hmm. Okay, so what do we think this limit is equal to?
Probably 1.
Probably 1.
Why are they the same on both sides?
Because of the symmetry of sine. Sine is an odd function.
I see a piecewise function if I gander down a little bit.
All right. Let's try this one. So, final one we're looking at from this scenario, our tables. It's also approaching 0. So go back to plugging in your, so you have -0.1, Angela -0.01, Caitlin -0.001, Sam +0.1, Grant 0.01, Carson Grayson 0.001.
Oh, the sign goes on the outside, right?
Yes.
Oh, I don't think my answer's.
Oh, interesting. Interesting turn of events.
It's 0.
Interesting.
Also 0.
Interesting turn of events.
Isn't it?
Is it also 0?
All right.
Interesting.
So what did we get?
0.
What?
Everybody got 0?
I didn't put it wrong.
Okay, so what do we think the answer is?
No solution.
Why?
Because sign can't be 0.
Why
You
can't
can't have a
sign?
0 in the denominator.
But we're not asking,
No.
we're saying as we approach. Let's look at it. If we graph,
Pi over 0 is wait, no,
so if we graph sine of pi over x,
Oh, it's at an asymptote, isn't it?
and if I look at this,
Oh, hello?
okay, if I zoom in on this,
Wait, that looks fire.
if we zoom in some more, the closer we get to 0, the crazier our graph is going. It is constantly oscillating back and forth. So if I just looked at my tables, I might have said 0, but if I'm looking at this, is it approaching 0? No, not at all. So I wanted to show you, this is misleading sometimes. That's why we are approximating, guessing, and giving our best shot. But the big red flag was that every single answer gave us the same thing. So that's a big clue that this probably doesn't work. So this one we would say does not exist. We usually just write D and E for does not exist instead of writing it out in words. So that is our first case of a limit that does not exist. I'm going to do 1 or 2 more and then I might jump ahead on notes just a bit.
Oh.
Yeah, let's.
So let's go ahead and look at this one, but I want to do it not by making a table but by drawing a graph.
So,
Okay. Oh, that is crooked. So x divided by the absolute value of x. I already gave you the piecewise definition. If you plug in a positive, you get 1, because it's x divided by x. So if x is greater than 0, we just get out 1. So if you put in 1, you get out 1. If you put in 2, you get out 1. If you put in 3, you get out 1. This is starting at 0. But it's an open circle because can you actually put in 0 here? No. Okay, and then we get -1 if x is less than 0. So what would that look like?
an open circle at -1.
And it's going left. We graphed piecewise functions in our first chapter as review. So if you needed to make a t-chart or something, you could. If I'm looking at this, as we approach 0, does this limit exist?
No.
As I approach 0 down here, my answer is -1. But as I approach 0 up here, my answer is +1. So if we had made the tables, the 2 tables don't match. That's another case where it does not exist. For the limit to work, the left and right have to match up. Because there's a break in our graph here, they don't match. So that's why it does not work out.
Ooh. So we gotta pay attention to the negatives too, don't you?
Have to pay attention, yes.
Chapter 9.
Let's go to We'll go ahead and do the next example, and then so if I wanted this limit as we approach 0. So if I graph this, 0 if t is less than 0. So we have to start with 0, put in 0, but it's not equal to, so it's open. Less than 0, so if t is -1, we get out.
0.
It's -2, we get out.
0.
So we just have this horizontal line at 0. Alright. 1 if t is greater than or equal to 0. So if I put in 0, I get out. If I put in 1, I get out. 2. So this is like that. So very similar, except I do have a closed circle at 0. It's like a horizontal line, because there's no variable in that.
It doesn't matter either way. right?
Oh, okay,
It's
yeah,
like
I got it.
being-
So as we are approaching 0, if I'm coming in from the left and right, I don't match up, so that means
the being-
it does not exist. All right, I want to jump ahead to the example with the graph, and that is our final one for today.
Which one?
This one.
Oh, yay.
All right, tomorrow we are going to talk about one-sided limits if we're only approaching one side at a time. And that's what this notation says. The limit as x approaches 2 and a little negative. That means from the left. As you are coming in smaller than 2. So if I'm on this graph, but my x is less than 2, and I'm traveling in over here, right? So as my x goes to 2, what's my y going to?
3.
3. Okay. As I approach 2 from the right, so I'm coming in from the right, bigger than 2. And as I'm traveling in towards 2, what's my y approaching?
1.
What does C say?
When x is 2.
As we approach 2, but there's no plus or minus, so that means from both sides at once. So as I'm coming in from both sides at once,
It does not.
they don't match. So that one does not exist. Okay, so it could exist from one side, but in order for the overall limit to exist, they have to be the same from the left and the right. So if I want, as I approach 5 from the left, so I'm coming in towards 5, I'm smaller than 5. So what's y value are we approaching?
2.
2. As I approach 5 from the right, so I'm coming in towards 5, but I'm bigger than 5. My y is approaching.
2.
If I do, this means both at the same time, coming in from left and right. Do my fingers match up?
Yeah,
No.
there too.
Yep, it's still at 2. Because both the left and the right hand limit match.
Oh, because it's got the same line. Got it.
So we don't care that it's an open circle because the limit doesn't care what happens at the point, just as we approach it.
So on the 2 with the negative when we're going from the left,
Uh-huh.
why do we start at 3? Why isn't that line like continuous?
Well, okay. Here's when x is
Why are
2.
we going away from 2?
Well, I was getting close to, here's when x is 2. I was traveling on my blue line, coming in from the left.